In this video, we're going to have a discussion with this distribution of the sample proportion. So in the last section, we discussed determining the sampling distribution of the sample mean. Now we discuss how to determine the sampling distribution of the sample proportion. Suppose that a random sample of size n is obtained from a population in which each individual either does or does not have a certain characteristic. The sample proportion, denoted by p hat, is given by p hat is equal to x divided by n, where x is the number of individuals in the sample with a specified characteristic. The sample proportion p hat is a statistic that estimates the population of the proportion. All right, let's take a look at an example. Suppose I randomly selected 200 students and asked if he or she will take summer classes. Of these surveyed, 75 students said they would take summer courses. Calculate the sample proportion of the students who will take summer school classes. So p hat equal to 75 over 200. This reduces in the lowest terms as 3/8, and you can write that as a decimal, 0.375. Now, how can we get a better response for this? Take as many simple random samples with n equal to 200 as possible. Keep in mind the sample proportion each time will be different. So now p hat is a random variable, so it has a probability distribution. The sampling distribution of the sample proportion p hat, that's the probability distribution of all possible values of the random variable p hat computed from a sample size n and with a population proportion p. Okay, let's take a look at this example. Based on a study conducted by the Gallup organization, 76% of Americans believe that the state of moral values in the U.S. is getting worse. Describe the sampling distribution of the sample proportion. So, as we go from left to right, as n equal to 10, n equal to 25, as the sample sizes increase, what is the distribution getting closer and closer and closer to? Well, that is going to be normal. Now, what do you notice about p hat as the sample of n increases? Well, p hat is 7600s here, here, and here. So p hat stays the same. Now, notice with the standard deviation, on the other hand, it is decreasing. And I am going to make this other note down below now. As the sample size n increases, the distribution becomes approximately normal. So, the sampling distribution of p hat for a simple random sample of size n, where n is no more than 5% of the population size and with a population proportion p, the shape of the sampling distribution of p hat is approximately normal, provided that the inequality n times p times 1 minus p is greater than or equal to 10. The mean of the sampling distribution of p hat, that's going to be the population proportion, and the standard deviation of the sampling distribution is going to be the square root of p times 1 minus p all over n. Okay? Now, one requirement of this model is that the sampled values must be independent of each other. That should hopefully take care of that the sample is less than or equal to 5% of the population. Okay, let's take a look at an example. A Pew Research report indicated that 37% of teenagers 12 through 17 own smartphones. Suppose a random sample of 150 teenagers are asked. Verify the requirements have been met using the sampling distribution of the sample proportion. Okay, there's three things, right? Number one, we know is simple random sample. 2, let me write this out now. 150 is less than or equal to 5% of the population of teenagers 12 through 17. Now, I need to check the sampling distribution. So we hope that n times p times 1 minus p is less than or equal to 10. Well, in this case, n is 150, p is 0.37, 1 minus 0.37 is 0.63. When you put that into the calculator, you get this, which is certainly greater than or equal to 2. So what does that mean? The sampling distribution of the sample proportion is approximately normal. Okay, let's take a look at part B. Determine the mean. So the mean, p hat, that is equal to the proportion, that's 0.37. Standard deviation, well, that is going to be square root of p times 1 minus p all over n. That'll be 0.37 times 0.63 all over 150. Writing out all the decimals, we get this. Keep in mind, I'm going to write all the decimals out because I'm going to be using this information for the next couple of parts here. Okay, let's take a look at part D. Calculate the probability that in a random sample of 150 teenagers, more than 35% own a smartphone. So, more than 35%, that is going to end up being, well, first of all, as a decimal, that's 3,500, 3,500s to infinity. So, now that we know that the sampling distribution of the sample proportion is approximately normal, this is, again, another normal CDF. So, normal CDF of 3,500, comma, 100,000, comma, now the P, which is 0.37, which is the mean, of course, and then the standard deviation. Rounding that to 4 decimal places, we get this. Okay, so I'm going to write an interpretation for this problem below. The probability that in a random sample of 150 teenagers, more than 35% own a cell phone is 0.6940. Okay, let's take a look at part E. Calculate the proportion that in a random sample of 150 teenagers between 38% and 45% own a smartphone. Okay, that's 0.38, that's 0.45. So, normal CDF 0.38, comma, 0.45, comma, the mean, comma, the standard deviation. That's this. So below, I'll write out another interpretation for this problem. About 38 out of 100 random samples of 150 teenagers, 12 through 17, will result in a sample proportion between 3,800 and 4,500 inclusive own a smartphone. Okay, let's take a look at the next example. So calculate the probability that in a random sample of 150 teenagers, more than 60 own a smartphone. That 60 is not a percentage. We need to figure that out. So 60 out of 150, you can put that in the calculator. That's 4/10. It's more than, so it'll be greater than 4/10. So normal CDF 4/10, 100,000, comma the mean, comma the standard deviation. And this is approximately this. Okay, one more example. Would it be unusual if less than 45 of the 150 sampled teenagers own a smartphone? Justify your position. Okay, so first off, 45 out of 150, put that in the calculator, that is 3/10, so we're talking less than. All right, normal CDF, that's going to be negative 100,000, comma, 3/10, comma, the mean, comma, the standard deviation. And I get this. So is this unusual? Well, since the probability is less than 0.05, the answer to that is yes. So let me write that out. So yes, this is unusual since the probability, which is about 0.0379, is less than 5/100ths.